Hey guys, Mr. T here, just doing another video. This one is on probability and experimental probability. So the study of probability deals with the chance or likelihood of things, the proper word for it is events, occurring. This chance or likelihood, which is really should just be summarized with the word probability, is assigned a number between 0, which is no chance of occurring, and 1, which means it will definitely occur. So there's two types of probability we need to deal with. One, experimental, which we'll deal with in this video, and two, theoretical, which will be later. So experimental probability. The experimental probability of something is a probability you get by observing the results of an experiment. So that's key here. When you talk about experimental probability, it involves an experiment that you've collected data on, and you're just basing your thoughts of the chance of something happening based on what's happened before. Now, to fully understand probability, there's some terms that you need to understand to start off with, and these help with experimental probability. Number one is the number of trials. That's the total number of times you ran an experiment and repeated it. Second thing is outcomes. These are the different results that are possible from one trial of the experiment. So say your experiment was flipping a coin, well, the outcomes are heads or tails. Frequency is the number of times a particular outcome is observed. So that might be the number of times you found you got a head from coin flips. And relative frequency is the frequency of a particular outcome, and you express it as a fraction or percentage compared to the number of trials. So the relative frequency is going to be the frequency of something happening that you're interested in divided by the total number of times you run that experiment. So these terms allow us to define the idea of experimental probability, which is the relative frequency of a particular outcome of an experiment. So there's some particular conventions that you need to use when dealing with probability mathematics. The way that you write them is capital P, and in brackets is the event that you're interested in. You can write it as words, sometimes it's just going to be a capital letter or some sort of variable, and that's going to equal some sort of number x, but x is going to be a number between 0 and 1, or sometimes you can express it as a percentage by timesing by 100%, so it's going to be between 0 and 100. Now the probability of an outcome not occurring is known as a complementary event. So sometimes people treat that as a separate topic, but it's easy enough to talk about it here because it's just the probability of an event not occurring. So it's like the opposite chance of something happening. And that's just going to be capital P. Now, whatever you used for the event, if you put a dash next to it, that means the probability of the event not happening. That dash shows that it's the complementary event. And that's always going to be 1 minus the chance of the thing actually occurring, because probability is between 0 and 1. So to work out the chance of it not happening, it's going to be 1 minus the chance of it happening. So let's do an example to sort of summarize all this information that we've gone over. So the example is a small plastic cup tossed into the air 300 times. It fell on its side 203 times and on its base 97 times. So 1, state the number of trials. Well, how many times did I throw it in the air? How many times did I run the experiment? 300 trials total is the number of trials. B, state the possible outcomes of a trial. So it's either going to land on its side or base. Those are the two possible outcomes of an experimental trial. C, state the frequency of the cup falling on its side. Well, that's just how many times it fell on its side, which is 203 times. D, state the frequency of the cup falling on its base. Well, it fell on its base 97 times. E, state the relative frequency of the cup falling on its side. So remember, relative frequency is the frequency of the event we're interested in, so falling on its side, and it fell on its side 203 times over the total number of trials, which was 300. Okay, so we do need to check if that fraction is in simplest form. I don't believe it is, but we'll see. Does 2 go into 203? No. Does 3 go into 203? Does 7? 7 does, but 7 doesn't go into 300, so I believe 203 over 300 is in simplest form. F. Calculate the experimental probability of the cup not falling on its side. Give your answer as a percentage. So, this is going to bring a few things together, specifically the idea of complementary event. So, the probability of it not falling on its side. So the event is side, but if I put a dash here, I'm saying it not falling on its side. It's going to be 1 minus the probability of it falling on its side, which is 203 on 300. So work that on the calculator, 203 divided by 300. 1 take that is going to be 0.32 to 2 decimal points. Times that by 100% equals 32%. So it's got a 32% chance of not falling on its side. The other way that you could do that is just go probability of falling on the base. Okay, and you don't need to do this 1 minus thing because you know it fell on the base 97 times out of 300. If you go 97 divided by 300, you get 0.323 recurring again, so round it to 2 decimal points. Times that by 100%, you're going to get 32% chance. Alright, so that is some probability terminology and also experimental probability and some examples of working that out. Hopefully that helps you out, and I'll see you in the next video.